So Manoj asked me a question that there is a plane lamina, and in this plane lamina, this isosceles triangle has been cut out. Means this part has been taken out, and this is the remaining part, and this is the point P where this is a vertex, and this plane lamina is horizontal, and this plane lamina horizontal plane lamina is placed upon a needle such that the this point P is just above the needle. Okay, and now in the system is now this whole system, the final system is in the equilibrium. Okay, so if the system is in equilibrium, this means that the center of mass of this final object, this final object is at this location, the point P. So we have to calculate this h, the distance of this isosceles triangle and the height of this isosceles triangle. So how do we proceed? So since this object is at equilibrium, this means that the center of mass is at the point P. So what we can do is that we know that the center of mass will lie along this line PQ. Okay, so this means that this orange object, this orange object has the center of mass along line PQ, and similarly this left hand part, this object will have the center of mass along this line PQ. So both the left hand side and the right hand side will have the center of mass along the line PQ. So we will calculate for this right hand side object, this orange object. Okay, so the center, so we divide this object into two part. One is this rectangular part, another is this triangular part. So this rectangular part have the length L by 2. This line is L by 2 and this line is L minus h. Okay, so the center of mass of this rectangular part from this PQ line will be at L minus h by 2 distance from this PQ line, and the center of mass of this rectangular part from this PQ line will be at h by 3 distance from this PQ line, this h by 3, and we have taken a minus sign because we are going in the opposite direction. So this is the right direction and this is the opposite direction. Okay, so here we are also considering that the mass the respective masses of this rectangular and triangular are m1 and m2. Okay, so for equilibrium it is necessary that the center of mass of the final system must be at point P. Hence YC, this is the definition of center of mass. So YCM is equals to Y1 M1 plus Y2 M2 plus M1 divided by M1 plus M2. YCM will be 0 because we are taking the origin at this above this line. So we are considering the origin above this point, this line PQ. So this is our origin. So the origin is above this line PQ. So the distance of center of mass of this rectangular object from point O will be L minus h by 2, and the center of mass of this triangular object from point O will be at h by 3. So here y1 is L minus h by 2 m1 plus y2 is minus h by 3 m2. Okay, and there is a denominator m1 plus m2 that will become 0 because YCM is 0. Why YCM is 0? Because the distance of the center of mass from lie on this PQ line, means above the origin. So from this we get this equation. So this is the equation number 1. Now we are considering that the lamina is uniform, means the surface mass density is same at every location. So this is the surface mass density of the rectangular lamina and this is the surface mass density of the triangular lamina. Here these are the side of this of the rectangular lamina, and this is the area. So this is the area of the rectangular area, and this is the area of the triangle. So right angle triangle. So what is the area of the right angle triangle? 1 by 2 height into base. So this is the formula for the area of the rectangular triangle. So this we have used here 1 by 2. So this rectangular piece has the base length L by 2 and the height is h. So we have used this and we got the equation number 2. we have divided equation 1 by equation 2 and we are getting the answer is this. So we have calculated the height L3 minus root 3 divided by 2. So this is the height of this isosceles triangle which we have cut out from this whole lamina. Okay, so now I hope your doubt is solved. Manoj Kumar, thank you.